Well, good evening. Good evening from here in the Isle of Man to what I hope will be an interesting lecture for you as part of Viking Television's Space Week. I'm sure some of you are aware that the International Space Week is celebrated at this time of the year every year to commemorate the fact that on the 4th of October 1957, Sputnik was launched from Russia and the space age started. And just look where we are now with all that's going on and doing virtual cruises online and all this sort of stuff. It's fascinating and it's great to be part of it. I do hope you enjoy the lecture, which is basically the story of Mr. Hubble and his amazing telescope. It's a lecture I've presented on board a number of times, so I hope you enjoy it. I will be taking questions and answer a Q&A session at the end. So if you have any burning questions you want to ask, feel free to ask me via the internet. You need to go onto the Viking.TV webpage and have a look for that, and we'll hopefully be able to answer any questions you may have. But let's get on with it. So Mr. Hubble and his amazing telescope. This is basically the story of the telescope that was built by Edwin Hubble. Well, sorry, start again. It wasn't built by Edwin Hubble, of course. Edwin Hubble was the gentleman that the telescope is named after. And if we go to our first slide, we'll see that we have a picture here of Galileo. And it was Galileo in 1610 who first realized that you could use a telescope and actually turn it to the heavens and see more features in the night sky. The telescope was actually invented by Lippershey in Holland the year before, but Galileo realized it could be used to look at the stars, and telescopic astronomy began. This was very quickly followed by other great scientists such as Newton on our next slide. And Newton, of course, famous for his book Principia, which was one of the books that really started out what we call the scientific revolution, when we moved from basically understanding about the stars with the naked eye to using telescopic astronomy, and he confirmed the force of gravity, which was a major discovery that he made. And of course he built the first ever reflecting telescope, even today known as a Newtonian reflector. There are two fundamental types of telescope. We have the refractor, which is using lenses like Galileo built, and we have the reflector that Newton built. And most astronomical telescopes, and indeed the Hubble Space Telescope, is a basic Newtonian reflector. It's changed, there's all sorts of names for it, Cassegrain, Schmidt, all this sort of stuff. But fundamentally, it is a telescope that uses a mirror principle. Now, big telescopes can be built, and the next slide shows, in fact, the next slide we have is of a much larger telescope. This is the large telescope built at Yerkes in Wisconsin, and this is a refracting telescope. It's a mirror lens telescope, and it's as big as you can get without having problems of what we call either chromatic or spherical aberration. Now, I'll be coming back to the subject of spherical aberration in a moment when we learn what happened to the Hubble Space Telescope. This particular telescope now is a museum piece. It is still operational. You can go and you can visit it if you live in Wisconsin or the United States. And I understand it's an amazing spectacle. And you consider this was literally over 100 years old now. It really was cutting edge technology. But of course, after that, we went on to much bigger reflecting telescopes. And the next one of those is the one at Mount Wilson. This is the 100-inch telescope. That means the mirror at the end of that cage you can see on your right-hand screen there is actually 100 inches in diameter. This was the telescope that Edwin Hubble worked at and made his famous discovery in 1923 about the existence of galaxies beyond our Milky Way. This was very, very revolutionary work. Big, massive telescope. Ironically, under great threat from the California wildfires not long ago, but thankfully those did not do any damage to the actual telescope, I'm glad to say. But here, if you look on this picture on the left, you'll actually see Hubble there, and on the extreme left of the picture there, you can see Einstein. Einstein actually visited Hubble a number of times at Mount Wilson, and they discussed all sorts of stuff about the universe and the discovery made by Hubble, which actually Einstein admitted made one of his theories an error. He admitted the greatest blunder of his life was caused because he didn't take into account something that Edwin Hubble realized back in 1923. But if we move on, the telescope at Mount Wilson was then followed by another big telescope, this at Mount Palomar, and this was twice the size, the 200-inch telescope at Mount Palomar you see here. One big massive mirror cell, imagine the weight of that, and the engineering required to build that telescope was absolutely immense. Now, we often talk about astronomers and scientists and the work that they do, but at this point I think it's appropriate to praise the engineers, because it's the engineers who take the scientists' ideas and make them work, and that's a great credit to engineers all over the world. Hubble actually went on and worked at Mount Palomar until his death in 1953, and I sometimes wonder that perhaps I'm fascinated by Hubble because he died just before I was born. So I don't know if there's a connection there, but it's something that I learned when I was getting this lecture together many years ago, that he died sadly just after I was born. But that's the Mount Palomar telescope. But we go round the clock back now to about 1900, so 120 years ago. We used to believe that the universe was both static, stable, totally unchanging, and nothing was basically going to change. We believed the universe comprised just one single galaxy, but this, as I say, was going to change. Along came a lady astronomer by the name of Henrietta Leavitt, and Henrietta Leavitt actually discovered there was a relationship between stars, what we call the period luminosity relationship, and this gave astronomers the ability to measure how far away distant stars were. It really was a major discovery, and Hubble was to use this to very great effect to show how far away things were. Sadly, poor Henrietta Leavitt, who incidentally was profoundly deaf, she received very little recognition for her work during her lifetime, and it's a pleasure to be able to mention that today, because she really was someone who pushed the envelope, as it were, on the subject of astronomy. But Edwin Hubble, was able to use this to great effect and discover many great things. And he discovered on the next slide that basically the universe has got more galaxies in it than our own single galaxy. And this short video just tells you a little bit about exactly what Hubble discovered.
In the 1920s, astronomer Edwin Hubble came to work at the Mount Wilson Observatory in Southern California. The observatory offered some of the most advanced technology of the time. Using George Ellery Hale's magnificent telescope, Hubble photographed the nebulae, faint clouds of light that were a mystery to astronomers. When Hubble examined his photographic plates, he discovered a Cepheid, a kind of star that varies in brightness over a period of time. Hubble studied the variation in brightness and used the data collected to calculate the distance to the star. By his calculations, this star and the galaxy it's a part of were much further away than anyone had ever imagined, and the universe was much larger than the Milky Way galaxy.
Now, this discovery was really quite profound, because up until that moment we believed there was only one galaxy in our universe. Hubble discovered the Andromeda galaxy, was a feature we knew in the sky, but he worked out by using Leavitt's period luminosity relationship, but in fact that galaxy was a separate galaxy to our own. It's actually now one of billions of galaxies. We often use the expression that there's a grain of sand for every star on the universe, and there's also a grain of sand on our Earth for every single galaxy in the universe. So we went from one galaxy to two. And incidentally, at this time of the year, if you know your stars at all, and if you look at the square of Pegasus in the northern skies, you can see the northern, the square of Pegasus and Andromeda and all those features in the sky. And the Andromeda galaxy is very easy to spot, one of the faintest objects you can see with your naked eye, discovered by Hubble to be a separate galaxy. It's often called a near neighbor, and that is the equivalent of Manhattan is to Queens, or Los Angeles or San Francisco is to the other side of the Golden Gate Bridge. Near neighbors is the point I'm trying to make. Well, the Andromeda galaxy is a near neighbor of ours, and it's 2.5 million light years away. Light year, of course, being how far light travels in 1 year at 1,860 miles a second. So I'll let you do the math yourselves. So that's what Hubble discovered. But he discovered as well that as a consequence of what he discovered, and our next slide shows us this, that there's not just one galaxy, there's other galaxies, and they're moving away from us. Therefore, there's an implication. If they're moving away from us, then at some stage or other, they must have been nearer to us. So the universe is expanding. And this led rise to a very profound statement, if you like, and that gave rise to something that the next slide will show you. The Big Bang. And this is where the Big Bang theory comes from. And before the purists tell me, yes, we know there was no sound for the sound waves to propagate into, but it makes great videos to show it with the sound of the explosion. So here you've got the Big Bang. And at the moment of the Big Bang, the universe was compressed into a tiniest particle, and this was approximately 13.77 billion years ago. Incidentally, one of the discoveries that the Hubble Space Telescope has made. After this, we had all sorts of things going on in the universe, but the universe then expanded, and as you saw on that previous slide. But basically, telescopes were born. Edwin Hubble used them to great effect, and the Hubble discoveries and everything proved that the universe does not comprise one galaxy, but multiple galaxies. But then think about when we are on the Earth. When we are on the Earth's atmosphere sustains and protects us, but light waves do not penetrate down to ground level at all parts of the electromagnetic spectrum. This slide here shows in the middle to the left the colours of the rainbow when you split light into its constituent parts. Incidentally, very lot of work was done by Newton on this, and this shows the light that or the parts of the EM spectrum that reaches the ground level. Radio waves, great, get right down to ground level, which is why they've got the big radio telescope in Manchester, where it rains all the time. Apologies to people watching in Manchester. But if we want to see features of the night sky in other wavelengths, we need to put telescopes on top of mountains where there's no water vapor or less water vapor, or there is another alternative, which of course springs to mind. And with the launch of the space age, as I say, 63 years ago, yesterday, it was very quickly realized that maybe we could use something like a space telescope, and that would be something that we could use and send into orbit. And that's exactly what was planned. Using an orbiting space telescope, this is a picture taken from the 8-meter diameter dish of the Subaru telescope in Hawaii, and the next picture shows the same picture taken with the Hubble Space Telescope, incidentally, before it was fixed. Even though it had huge problems, it was still able of taking some good images. But by using a space telescope, we could get higher quality images. And as the next slide shows, the idea was that in 1968, the idea of building a telescope that would fit on the top of a spacecraft and could be sent into space. The biggest diameter mirror we could build comfortably to launch into space was 96 inches, just 4 inches less diameter than that at Mount Wilson. In 1983, it was agreed unanimously when the telescope was agreed to be built that it would be named after Edwin Hubble, who incidentally never received a Nobel Prize. He died before a prize could be presented to him or offered to him. And this mirror on this telescope was manufactured to a very, very high and precise specification. In fact, the plus and minus tolerances of this mirror were well within what they'd forecast they could do. It was made perfectly, but perfectly wrong, unfortunately. The Hubble Space Telescope was meant to be launched in the early 1980s, but various delays and overruns and budget problems and everything else meant that it was meant to be launched eventually in 1986. It didn't get launched in 1986 because sadly the Challenger disaster took place and the telescope was mothballed and put into the NASA facilities at Maryland at the Goddard Space Flight Center, and there it sat. With hindsight, they could have done more testing on it and maybe discovered what the problem was going to be. But it wasn't. It was eventually dusted off and launched, and it finally got launched, as it shows on the next slide, on the 24th of April, 1990. 30 years ago this year.
13 seconds. T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
So there we have the telescope launched on April 24th in 1990. It was, of course, going to be something very special, and everybody watched and waited, as they just said on that video. They watched and waited to see what was going to happen. Well, the astronauts the next day deployed the telescope, as you just saw, and then they started to look at the images. And the next images they saw after it was deployed.
With the sea and clouds of Earth reflecting on its door,
You can see the Canada on
great
there
silver
drifting
bird
away
was
from the
released to
telescope.
soar in orbit,
There's actually no sound on this
320
one.
miles above us.
Yes, there is sound on this one, of course. Just remember it's the other one at home.
Astronauts would return for regular house calls to upgrade and replace parts as needed. Soon, they would be sending images back to us. Would we discover other worlds like ours?
The shuttle is actually
finally
pulling
unlock
away
the
from the telescope
secrets
at
of
this
the
point,
universe?
not the other way around.
The whole world waited for Hubble to open its enormous eye.
But, and this is where the problem started, we realized when they opened the door, that beautiful door of the telescope there, and they found out that the images they were getting from it suffered rather badly. This image here shows a ground-based image of a particular star, and this particular star from ground looks like that. From the Hubble Space Telescope, it looked like this. This is the star 34 Melnick. Those concentric rings you can see around that there are flaws. They should not be there. The star should be pristine, a lovely, clear, precise star in the central part of that image. Spherical aberration was the problem. And spherical aberration and chromatic aberration are the two problems you get with telescopes when you're bringing a large instrument, you're passing light through it, and that light comes to a focus at the prime focus of that instrument, of that lens or that mirror. Well, if the light does not come to a focus at that exact point, you get subtle changes, subtle differences, and spherical aberration was what the Hubble Space Telescope was going to suffer from, or did suffer from. NASA were horrified, the scientific community were horrified, and they realized very early on that something had to be done. If we look at the next picture, we can see the mirror in the process of being built. This mirror here now, you can see that's the size of the actual mirror, and the precise specifications. Unfortunately, the specifications were wrong, not the manufacturing. And that, as a consequence, meant that the edge of the mirror was a flat by 4 microns, a quarter of the width of a human hair. That is enough to give that problem we saw on that image a moment ago. Well, the media, as ever, were horrified by this, and they made fun of it, and NASA were criticized, as it shows on the next slide. They were criticized immensely, and they made the film Naked Gun 2.5, which shows world's greatest failures or world's greatest problems: San Francisco earthquake, the Hindenburg disaster, one you shouldn't refer to on a cruise ship, but the Titanic disaster. And there in the foreground, on the par with those three great disasters, was the Hubble Space Telescope, NASA's $1.5 billion blunder. It really was horrific. It really was something that NASA and the scientific community were totally horrified about, and wished that obviously that it was not the case. There was a bit of humour at the same time, however, because at the same time some of the cartoons came out in the various magazines, and I particularly like this one. Well, maybe space really is blurry and out of focus. Or maybe this one. Maybe send an optician up. But the best one, I think, is this next one. Send up a team of astronauts and fit the Hubble Space Telescope with contact lenses. And you know, in some respects, that's exactly what they did. They realized that they had to change the path in a very simplistic way. They had to change the light so that the path of the light had longer to go. So what they did, they put in the telescope, something like a telescopic pointer I'm using here, and they put a little mirror there, they put another little mirror here and a little mirror here, and the light came in, hit one mirror, went to the next, and then went back where it was meant to go. They lengthened the light path of the part of the radiation, of the electromagnetic spectrum they had to do. Great, relatively easy to fix it, but it's 250 miles up. How on earth are you going to do that? Well, NASA were determined to fix the Hubble Space Telescope. At one point, they thought they would just literally deorbit it and let it burn up. They couldn't go and collect it again. It would be far too expensive to do that. They had to fix it. It was meant to be serviced. The whole point was the Hubble Space Telescope was meant to be serviced by astronauts. It had been planned to do that from the outset. So they devised what they call the CoStar device, and this was a package of instrumentation that took my little stick, if you like, with the little tiny mirrors in it, and they took it and they trained extensively how to use it in the neutral buoyancy tank at Houston, Texas, the world's largest swimming pool, it's once been called, and tested and tested and tested, and the astronauts practiced and practiced and practiced, and eventually, over 3 years later, they were ready to see if their fix would work. And this next slide here shows the launch of what was probably the most important space mission since the Apollo landings, when STS-61 Endeavour was launched in December 93.
And we have a go for main engine start. 5, 4, 3, 2, 1. And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
What's particularly impressive about that film is even at that point, NASA were not repairing the Hubble Space Telescope. They were servicing it. It was already meant to be serviced. It was originally always meant to be serviced. And indeed, that's what they did. So after the launch, they got back to the Hubble Space Telescope the day later because the launch was such that they would rendezvous with it. You can see here the solar panels. They were going to replace the solar panels anyway. One of the most famous images of that servicing mission is one of the astronauts letting the panels go, and it literally seemed to float like a giant dinosaur as the Earth's atmosphere grabbed it and it slowly started to decay. But after the successful rendezvous, work began. And after about 70 hours of spacewalks and getting everything ready, they were ready to deploy it. Now, there's no sound on this particular video here, but you can see here the calendar arm, that remote control arm that they used to grab and hold onto things. The calendar arm let the telescope go, and the telescope was set off to do its work. If ever there was an anxious moment when they opened the door of that telescope and tested it for this time, because if it had failed this time, I hate to think what the consequences might have been. But of course, it wasn't a failure. It was an outstanding success. As the next image shows, we have a picture now showing, this is just a picture from orbit, but if we look at the M100 spiral galaxy, which is a wonderful thing to see in any telescope, and you can see a pre-fixed image and a post-fixed image.
I can see clearly
a nice bit of sound.
Now the rain is gone.
Always nice to put a bit of music to a presentation if you can. So there we go. Thank you to Johnny Nash. So with so much relief that they've managed to fix the telescope, work could now start on using the telescope properly and getting it to do the work for which it was intended. It didn't take long before they realized there were some fantastic images they could take. As the next slide shows, this image, probably one of the most dramatic pictures Hubble's ever taken, the Pillars of Creation photograph, or the Eagle Nebula, photographed in 1995, a couple of years after it had been redeployed. And this picture was re-imaged again not so long ago, and this picture was taken at infrared wavelengths with another telescope, and you can just see the detail there, looking at infrared and at optical light, the wonderful picture of the Eagle Nebula, probably the most famous picture that Hubble has done for us. And if we move on to some other discovery pictures now, we saw the impact of Comet Levy-Shoemaker 9 on the planet Jupiter, and we realized that the work of Jupiter and its gravitational well, and indeed the other giant gas planets of our outer solar system, protect the Earth from being bombarded by comets in the comparatively recent period. There's theories that the comets that impacted the Earth way back in ancient history brought the water to the Earth, although that theory took a major knock a few years ago when the Rosetta spacecraft proved that the water on Comet Churyumov-Gerasimenko had a different type of water. But that's science. We move on and we ask more questions every time we get an answer. But Hubble, not just looking in the solar system, it also looked at the planet Saturn on the next image, and it showed that, sorry, this is Jupiter again. This is Jupiter because only a couple of years ago they discovered that on Jupiter, we know the moon Io, the innermost moon of Jupiter, got volcanoes, but we've also discovered that Europa is erupting water ice. Now, water and ice and all that sort of stuff in the outer solar system takes on different properties because of the intense cold temperatures. But to see erupting volcanoes from Jupiter's moon Europa, Europa basically is an ice ball, and we believe there are liquid oceans below the ice, and that gives the potential that life may originate, or primitive life could exist below the surface of Europa under the ice. So this great discovery from Hubble was probably one of its most momentous discoveries. Moving on, we also discovered that we hadn't thought of this before, but if you've got an atmosphere like you've got on Jupiter and Saturn, it's a gaseous atmosphere, and you've got a magnetic field, which you've got out those because you've got a spinning metallic core causing electrical generation, you get auroras. And we've now spotted auroras on all the gas giants, and indeed to a minor extent on the planet Mars, I understand. So these are some of the discoveries of the inner solar system, of the outer solar system, but we also discovered lots of other things in the rest of the universe, as it were. A beautiful image here of a planetary nebula. When a star goes through a certain stage of its life, it actually puffs off its outer layers, and this ring you see here, this one often called the eye of God, it does look like an eye, doesn't it? And it really is an amazing picture. And the next picture shows a similar situation, but this is a recurrent nova. This star has continually puffed off its outer layers, and we get different layers and different material visually from the Hubble Space Telescope, which really is quite fantastic when you look at them like that. Now, moving on again. This is the center of our own galaxy, the Milky Way, 26,000 light years away. Remember, this is our galaxy. This is 26,000, so it's very close to us compared to the Andromeda galaxy, but it's just an amazing picture looking at the star clouds in the middle of the Milky Way in the constellation of Sagittarius. And our next image shows another picture, this of the Sombrero galaxy, so named because of its shape, but by using another great telescope that NASA launched, the Spitzer Space Telescope, they were able to take a composite image of the two of them, and you can see even more detail there on the Spitzer telescope of the Sombrero galaxy. Just some amazing and fantastic discoveries that the Hubble Space Telescope has made over a period of years. In fact, the 30 years since it has been launched. But never mind all that. It's about time I gave you, the viewers, a chance to do some work. And I'm just going to introduce you to a short film now, the Hubble Space Telescope Deep Field Images. And this next slide is a short video which shows us just what we're talking about. If I let that play now.
It seemed utterly empty, a patch devoid of any planets, stars, and galaxies. This area was close to the Big Dipper, a very familiar constellation, and the patch of sky was no bigger than a grain of sand held out at arm's length. This was a somewhat risky move by the scientists. After all, observing time on this telescope is in very high demand, and some questioned whether it would be wasted trying to look at nothing. There was a real risk that the images returned would be as black as the space at which it was being pointed. Nevertheless, they opened the telescope, and slowly, over the course of 10 full days, photons that had been traveling for over 13 billion years finally ended their journey on the detector of humanity's most powerful telescope, their feeble signals collected almost one by one. When the telescope was finally closed and the images were processed, the light from over 3,000 galaxies had covered the detector, producing one of the most profound and humbling images in all of human history. Every single spot, smear, and dot was an entire galaxy, and each one containing hundreds of billions of stars.
Probably one of the most profound images the Hubble Space Telescope has taken. And for those of you who have seen me on board the ship, you'll know I always wear this tie for my Hubble lecture. This is the Hubble Deep Field, one of the deep field images taken by the Space Telescope. But as I say, it's time for you to do some work for me now. So if we go to the next slide, we'll see that since 1994, the Hubble has taken a number of these, what we call the deep field images. Imagine, astronomers tend to use the small and the big together. We have huge distances, but we use the very small to illustrate what we're talking about. So I want you to imagine you put a grain of sand on your fingertip, a tiny grain of sand on your fingertip, and stare at it for a number of hours. That's exactly what the Hubble Space Telescope did. And the first image you see there on the left was the deep space field image taken in 1996. The next picture was taken a few years later, imaginatively called the ultra deep field, in 2004, and then the extreme deep field images, which is the one on my tie, was taken a couple of years later in 2012. What's that got to do with some work you can all do? Well, what we need to do now is to take the whole sky and work out how big the sky is. So we can actually measure the whole sky. We know we have 360 degrees around our horizon, and from horizon to horizon, north to south, we have 180 degrees. So basically it's 360 by 360, but it's a sphere. So using the various mathematical formula, we can work out there are 41,250 individual squares in the sky, 1 square degree in size. Take just one of those squares now and split that into 400 smaller cells. Each one, of course, is 3 arc minutes square, if you do the math for that. And this little tiny square here in the middle, that is the size of the extreme deep field image taken by the Hubble telescope in 2012. So that's the image that you saw a moment ago. So now let's take that image. Let's take that individual image, and now let's split that into 16. Sorry, I jumped ahead of myself. So there are 400 of those small images in the 41,250. So 400 times 41,250 is, wonders of mathematics, 16.5 million. So that means there are 16.5 million Hubble Extreme Deep Space Field images in the sky as seen from our planet. Now then, let's go to the next stage and take that image and split that into 16. Remember what they said in the video? Every single dot, every single thing on that image is a galaxy. So we just take one of those squares at random, this one here. And now I want you all to look at your screens for the next 20 minutes and count how many dots you can count in that screen. But maybe we won't do that way. I'll cheat. I'll tell you, if you actually measure that precisely and using the relevant instrumentation to do that, you will actually count a total of 625 individual galaxies in that single cell. So now, and this is one of the most profound things that the Hubble Space Telescope found for us, because there was so much risk to doing this, but it proved itself, as I say, over 3 times. By extrapolation, if we take our 625, multiply that by 16, we have 10,000. Nice round figure. Now multiply our 10,000 by our 16.5 million. That gives us a total of, comes up in a second, here we go, 165 billion galaxies in the observable universe. Absolutely amazing discovery by the Hubble Space Telescope. And incidentally, if you go onto the Enterprise, not the Enterprise, the aircraft carrier in New York Harbor, and they show you the actual how they did this all those years ago. Amazing discovery. But the Hubble Space Telescope, as you probably realized, was made to be serviced. It was meant to be serviced by a team of astronauts, and eventually they did a total of 5 servicing missions to it. The first one you saw in 1990 was the first mission. The second one took place in 1997. This was the SM2 Service Mission 2 with STS-82. The third mission went up, and this was actually split into 2 because they had so much work they wanted to do. The first one went in 1999, and the second one, 3B, went on Columbia in March 2002. But just after them, we had, of course, the Columbia disaster. And the Columbia disaster in 2003 put paid to any plans to do any further servicing missions. And it was intended that NASA would not do a further servicing mission. But the astronauts pleaded to be allowed to do it. what basically happened was they said that they would launch only if the shuttle could get to the International Space Station in the event of a problem at launch, like happened to Columbia with the impact on the underside of the shuttle. So they decreed that only shuttles would be launched that could go to the ISS. And of course, to go to Hubble, you can't get to the ISS. The orbital mechanics won't let you do it. The scientific community were horrified and disappointed. The astronauts themselves said, look, we're prepared to go and do it again. It's too important not to do a final servicing mission. And eventually, just prior to the end of the space shuttle era in 2009, they launched STS-125. And here you see the two astronauts. The wings have been taken off. I say the wings, the solar panels have been taken off. And one of those astronauts in that picture is a chap called Mike Good, known as Bueno. And I had the great fortune to meet him at Cape Kennedy when I went to see a shuttle launch way back in 2009 and 2011. And I always remember just chatting to him, and he said, I was just a repairman. And he told us a famous story about a panel on board the telescope which they had to take off, what we would call here in the UK as Allen keys to take it off, small things, and there's a small panel to take off. And he had to wind these off using a zero gravity tool. And it took about 30 to 40 seconds to get each one of the 24 screws out. And he was stood there looking around thinking, gee, what a great place to have a workshop. Amazing bloke, and it was a great privilege to meet him. Such a nice chap, and fantastic experience to have done something like that. But the final mission, of course, took place, as we say, in 2009, and the Hubble Space Telescope is still working to this day. It's still working relatively well. It's got 6 gyros on board, but unfortunately 3 of the 6 gyros have now failed. But we do hope that they will be able to keep it going for some time. They can actually service it use it with just 1 gyro. They've got 3 left, so they're literally nursing them. They're not swinging the telescope all around the sky like they used to. They're looking in one particular part of the sky all the time, or certain parts near to each other, to try and preserve the integrity and the durability of those gyros. Eventually they will fail and the telescope will sadly be no more. There are no plans to bring it back. It's too big, it's too far away. They have put a capture device on it, and it may be that it'll be deorbited and burn up. There's lots of theories that they'll bring it back, or they'd like to bring it back and put it in the Smithsonian. I don't frankly think that will. Another telescope coming up, which we'll talk about in just a moment. But one of the great discoveries, someone has already asked me the question about the greatest discovery of the Hubble Space Telescope, and I glossed over it perhaps at the beginning, because the universe we always think is expanding, and it's starting to expand in various ways, whether it's expanding at an increasing rate or a decreasing rate. But the Hubble Space Telescope quite surprisingly discovered that the universe is still expanding at a slightly increasing rate, which went against all the theories that lots of astronomers have been saying the universe was actually not doing that, and that discovery by Hubble completely changed the rule book once again. Its second greatest discovery was more of a backup discovery when in 2017 it understood, or it observed, gravitational waves in optical light now, because of things that went on from this discovery in August 2017, which this short video will tell you about now.
The LIGO-Virgo collaboration detected gravitational waves rippling through the fabric of space-time. Just 2 seconds later, 2 space telescopes from ESA and NASA also detected a short gamma-ray burst coming from the same area of the sky. This coincidence had never been seen before and raised hopes that astronomers had witnessed a cataclysmic event.
And you might recognize that image from before. But of course, with any instrument, any sort of mechanical instrument, there can always be problems. And we did have a big problem that took place in October 2018, just a couple of years ago. And this problem was, again, with the gyros, as this next slide shows us. October the 5th, 2018, they suffered this serious gyroscope failure. October the 9th, a few days later, they basically put the telescope into safe mode while they worked out how to fix it. 10 days later, they actually fixed it by turning it on and off. And believe it or not, that's exactly what they did. And what made it worse was one of the spokesmen at NASA made this wonderful quote. At a higher level, if people want to call it jiggling around, I suppose they can. But we were trying to do very particular activities which we thought would clear the problem. It was certainly not just as simple as turning it on and turning it back off again. How many times on our computer do we all know, just reboot it, it'll do the trick? And that's exactly what happened to the Hubble. NASA scientists still deny that, but fundamentally they rebooted it. That wasn't the end, of course. There have been other problems with the Hubble Space Telescope since, and I was looking this up only last night to see what else has been going on. In 2019, we had a problem with the Wide Field Planetary Camera number 3. That's the third camera they've fitted, and this failed, but they managed to fix it again a few days later. And it was successful, back in use. And since January 2019, there have been very few problems with the telescope. The gyros are going to be the problem that will cause the eventual failure of the telescope in its entirety. And who knows what will happen then. At the moment, there are no plans to bring it back, but I'd like to think that maybe private industry might do it. There is a small spacecraft called the Sierra Nevada Dream Chaser, and they have suggested that they could go and do a further servicing mission and possibly replace the gyros and maybe keep it going even longer. As it stands at the moment, we estimate the Hubble Space Telescope will probably last to about 2025. It's funded at the moment till the middle of 21, but I'm sure it will be extended beyond that if it's still operating, as we hope it will be doing so. So, other discoveries the Hubble Space Telescope have made, all of them are quite momentous, but in 2019 there was another great discovery where they discovered the atmosphere of water and water vapor in the atmosphere of a planet beyond our solar system in what we call the star's habitable zone, or the CHZ or the CHZ. If you imagine a planet orbiting a star where water can exist on the surface all the year round, somewhere on that star, that is one of the prerequisites for life as we know it to evolve on another planet. And that idea has been, we've discovered lots of exoplanets, and that's another lecture in its entirety, the discovery of exoplanets. But this discovery by Hubble back in September 2019, just over a year ago, this was quite momentous because it discovered one of the basic building blocks of life existing in the upper atmosphere of that particular planet. So this particular planet is roughly 8 times the size of our Earth. It orbits a smaller red star about 110 light years away in the constellation of Leo. And Leo, of course, at the moment, if you're interested, if you get up early tomorrow morning and look for that very bright star in the eastern sky just before sunrise, that is the planet Venus. And Venus is going past the star Regulus, the principal star in the constellation of Leo, literally over the last period of the last few days. So moving on, the Hubble Space Telescope, of course, was 30 years old this April. It was 30 years on April the 24th this year. So to celebrate, they issued this fantastic image called the Hubble 30th birthday image. It's called the Cosmic Reef. The Cosmic Reef because it looks like something you'd see underwater. And NGC and New General Catalogue 2014 is the big red and blue one at the top, the right-hand side, and 2020 down below is a blue. It's a planetary nebula looking out there, and this particular fantastic image from Hubble, released for the 30th anniversary image, or for the 30th birthday, is in the Large Magellanic Cloud. We don't see that from the Northern Hemisphere, so anybody who's able to see the Large Magellanic Cloud in the Southern Hemisphere, that is where Hubble was looking when it took that image those years ago, only earlier this year. But what's next? Where do we go from here? Well, there have been plans to build a much bigger telescope called the James Webb Telescope, and for many years now it is scheduled for launch in the very near future. But this telescope has been a long time coming. This will not be placed in Earth orbit as the Hubble was. It's actually going to be put into what we call one of the Lagrange points, and the Lagrange points are gravitationally stable places in the Earth's gravitational field, balanced by that of the Moon and the Sun, and the telescope will stay there and not need to be in the shadow of the Earth or any other problems like that. And this is a very ambitious project because the mirror of this particular telescope is made of segments, and these segments will all fold in on itself, and then eventually it'll all fold out and be deployed as you see there on that image. The telescope itself is scheduled for launch. It's scheduled for launch shortly. I'll come back to that in a second. But this is the size of the Hubble primary mirror, and that's the size of the James Webb Telescope mirror. You can see those hexagonal segments are almost each the size of the Hubble mirror. It is a ginormous beast, and the technology they're using to build that really is quite incredible. And we're very hopeful it'll be a success. And this little video now just shows you the mirror cells in the process of being put together. You can see the crane is lifting the mirror segments there and dropping them into the cradles, and you can see the whole telescope being assembled, which was a couple of years ago now. It was actually finally assembled completely in August 2019. It's just quite an incredible bit of engineering. Again, credit to the engineers for doing what the scientists wanted them to do, and to such great precision. And hopefully that will be launched, as you see in this next slide. It is scheduled to be launched. It was down for 2021, but that has been moved back fundamentally as a consequence of the COVID-19 pandemic. The Space Telescope is ready, and unlike the Hubble, they've been doing what they call a full plugs out test of the whole thing, making sure that everything works together, and hopefully it will be successful. It's going to be launched on a European agency space rocket, the Ariane rocket from French Guiana, in Kourou, and that will be launched, as I say, in October 2021. It's a huge telescope, but of course there are other big telescopes now on the Earth, imaginatively named the EELT. We've had large telescopes, we've had very large telescopes, and now we've got extremely large telescopes. Someone should make the names of these things far better. But this one will have a mirror 39 meters in diameter, because using corrective optics, we can now get images at ground level which dissipate the problems of water vapor and the problems of not seeing through the atmosphere, and we can actually get better pictures in optical light from the Earth's surface than we can with the Hubble telescope, believe it or not, which is why the James Webb telescope is going to be looking at different wavelengths that we can't do things about from the Earth. And this just shows you the size of the mirror. Again, it's a hexagonal fragmented mirror, and the total size of this mirror will be 39 meters. An absolutely huge, massive telescope. Moving on. This is where it is. This is the in Chile, and they've actually taken the top of that mountain, and that top of that mountain was flattened to build this telescope on, and hopefully it'll be operational in the next few years. In the meantime, that's the European version, but there is another telescope planned to be put on Hawaii, the 30-meter telescope to be built on Mauna Kea in Hawaii, and that is also in the process of construction. They got planning permission finally to build that telescope only last year, and there was some of the native Hawaiians didn't want it building in that location, and I understand the authorities threatened to build it in the Canary Islands instead, and then the Hawaiians changed their mind and let them build it, or let them go ahead with the plan, which is what they're doing now. And that telescope will hopefully be built in the very near future. But where do we go from there? Well, the Hubble Space Telescope mirror at 2.4 meters in diameter is a very large telescope. And you can see here this image of the telescope here. This is the Hubble mirror against the James Webb mirror at 6.5 meters in diameter. And there's already plans for the next high definition space telescope with a just under 12 meter diameter mirror. And that may be launched approximately 2028, 2030, depending on funding and everything else. But no talk on the Hubble Space Telescope would be complete without my showing you some of the fantastic images that the Hubble Space Telescope has taken over the last 30 years. So I hope you will enjoy them. So I hope you've enjoyed those images, because I really think they're fantastic, and I could have put so many more images in that, but in the time we've got available, I hope you enjoyed them. And I'll leave the last word to Einstein. The only comprehensible thing in the universe is that it is incomprehensible. Thank you very much for listening. I hope you enjoyed it, and I look forward to seeing you back on board one of the Viking ships in the very near future. Thank you very much indeed. Now, as we said at the beginning, I'll be happy to take any questions, and I've had a couple of questions sent to me during the course of the lecture. One of them, what was the most surprising find of the Hubble Space Telescope? This is from Lisa in Sacramento, and I think I've already answered that. That was the one where the Hubble Space Telescope actually looking not only just at the age of the universe, which was another great discovery. I mean, where to start? There's so many discoveries that it's made, but the most surprising one would be that discovery that the universe is still expanding at an increasing rate. That was not expected. Modern theory was going the other way with that, and that discovery, and it's been confirmed, certainly was one that rewrote the rule book, as it were. One of the other questions we've had here from a chap called, sorry, I don't know, gender, Amitava in the United States as well. Are the batteries on the Hubble Space Telescope replaced? No, they can't be. Obviously, there are some power sources on. The main source of power for the Space Telescope is the solar panels. They're still working quite successfully and quite satisfactorily. They were replaced during each of the servicing missions, but there's no plans to do anything else now that the space shuttle has been retired, and we're moving on to using Dragon. Of course, the Dragon spacecraft being launched late this month, and also Boeing are launching their Starliner, hopefully sometime beginning of next year. And in the meantime, the Orion spacecraft, which is one of the reasons the ship, the Orion, was named, that will also be launching in probably about 2023 as NASA and the United States head back to the moon with the first woman and the next man. Someone else has asked the question, Alan from Myrtle Beach, will there be an effort to return it to the Earth? No, sadly there's not. That's not going to happen. Don wants to know, has the telescope seen many UFOs? The simple answer to that is no, it hasn't. And I just hope that's, if any more questions, feel free to ask them as we go through. Thank you for those who've asked those questions. I'd like to say hello in particular to our friends in the United States. It's a strange world at the moment where we need to do these sort of things, and we can't get on our cruise ships and do the things we'd love to do. But it's only a matter of time, and I know Viking are making every effort to get their ships ready. And I know where I live here in the Isle of Man at the moment, 3 of the Viking ships are being serviced and processed over in Northern Ireland, which is very near to me. And I'm sure the ships will be all ready for us as passengers and guests in the very near future, once this nasty little bug has been sorted out. But I'm afraid that's something beyond anything we can do. But as I say, if anyone's got any more questions, I'll be happy to answer them. I know I've got some people watching down in Australia, so hi to our friends down under. And oh, here we got another one here. This is from David, saying he grew up with Robert Bobby J-Roe but lost contact. He learned he was a contributor to the Hubble Space Telescope and a director of one of the missions to repair it. I don't know of his role, but I'll certainly look it up. That's a fascinating idea. You know, one of the great things about cruising with Viking is you meet people after the lectures, and they don't necessarily come up to you to ask you questions, but they come up to you to say that they work with somebody or they know somebody. I mean, Mike Good, the chap I met at Kennedy back in 2009, one of his neighbours came up to me after one of the lectures on board the Viking Jupiter earlier this year it was. And they actually said that Mike had just retired from NASA, which I knew anyway. And he said he's a lovely bloke. To have him as a neighbour, it was fantastic. And I remember thinking, it's just incredible. It's a great privilege to meet people who have had such careers throughout their working lives. That people tend to be retired or towards retirement age when you're on these cruises. And it's amazing the people you do meet. And I thoroughly enjoy it. And it's just a shame, as I say, we can't do it at the moment. But I'm sure we'll be doing it again very soon indeed. But thanks for that, David. Hit back to David Hilvers. Hi, David. If it's another David, well, hi to you too. But I know it's great to see and hear from so many different people. And it's interesting that most of you seem to be from the United States. I'm just scrolling through. Someone did ask me about the photographs behind me. This particular photograph behind me, just up that side, this picture here is actually a picture of me in space. I can't point to it. I'll do it that way. It's easy to do it that way. That picture is me taken in the window, our Astronomical Society here in the Isle of Man, taken by Nicole Stott, who went up on the space station twice. Nicole, a wonderful lady. She married a gentleman from the Isle of Man, Chris. And that picture was taken in the window of the space station. So when I give talks to children, which I do quite often, they ask me, Mr. Parkin, have you ever been in space? And I say, yes, of course I have. And there's my picture in space. And the other picture there is a picture of the Northern Lights taken in Alaska. And of course, you've got my Manx flag over there on above my shoulder. And you can see there behind me a picture of Buzz Aldrin, because when Apollo 11 was launched back in 1969, I wrote to all three of the crew, and that particular picture, which if I move that way, that's right, you can just see it there, it's actually to Howard Parkin. Best wishes, Buzz Aldrin. One of my prized possessions, as I'm sure you can understand. Another question here, why is the universe depicted in a conical rather than a spherical shape? That's a very good question, and I don't know the answer to that fundamentally. We believe the universe came out from a big bang, and it came out not necessarily in a huge sphere, but it came out in an elongated sphere, if you like, which is why we tend to show pictures of it in a conical shape. But the reality is it's in every direction at the same time, so it should be more spherical, but for depiction purposes, to show the expansion, we show this sort of cone feature that I showed in that image. Another question here from Roberta: what astronomy education would you suggest for children? I would suggest one thing you have got in the United States, probably more so than we have in the British Isles, is the museums and the galleries and the space centres. And one of my favourite things to do when I'm at home is going into schools and giving talks on space. If you know anybody who's an enthusiast, anyone who knows an astronaut, or anyone who's worked in the space industry, get them to talk to the children. They are just incredible. They're like little sponges. They soak up absolutely everything. And children are our future. They're the ones who are going to be building the space telescopes of tomorrow, the spacecraft going to Mars. And I can't stress enough how important education is to children. The STEM or the STEMmer idea of science, technology, engineering, maths and arts, very important. And but there's so much out there, and the internet is a wonderful source. I mean, last night, obviously I was giving this lecture, so I was just reading up again myself on the various features, and have there been any significant problems with Hubble in the last few 6 months or the last year or so? And thankfully there haven't, but it's amazing what we can see. Another question I've got here: what percentage of the known universes Hubble observed? Are we days, months or years behind analysing the Hubble images? The amount of work that's coming from the Hubble, the amount of images they're downloading all the time, I understand from one quote I heard from a scientist some years ago, is there are people now who are in high school who will be going to university, and they will do their doctorate, their thesis and all that sort of stuff based on a particular type of image and a particular feature of what they've discovered and what they've learned from. There's so much coming down, we can't analyze it all at once. And sometimes we have citizens science projects where the public are asked to contribute to them. They're not doing that with Hubble currently, but the amount of stuff they're getting down is incredible. I would say the answer to your question, we are years behind analysing everything. And of course, once we've got the Hubble, sadly, when it does pack up, we'll then hopefully have the images from the James Webb Telescope, which will be bringing us even more. Another question here from David. I don't know if it's the same David or not. What was the Astro 2 mission? Learned my friend Robert Jero was manager of that mission. I'm guessing the Astro 2 mission was probably the second servicing mission of the Hubble Space Telescope in 1997. I've not heard it referred to that. It's usually referred to SM2. But you mentioned on your earlier question about your friend Robert Jero worked on Hubble, so I'm guessing the Astro 2 servicing mission was probably that mission. I must look up his name and see if I know more about him, but it's amazing to hear of these people who know these people. Another question here from Roger in the United States. What's the photo process? I'm glad someone asked that, because that's one of the questions I tend to get asked when I'm on board the ship. And people see these images and they say, those images are fantastic, and you put them to music and it just adds an extra dimension to it. But how do we get those images, and are they true to life? Well, the Space Telescope takes its images in monochrome. All the images are in black and white, or degrees of black and white. But of course, they can analyze using computer scientists very cleverly exactly what is in that particular image. And they then process it using photo techniques to change it into color. They know the content of the picture. They know whether it's hydrogen or different types of hydrogen or oxygen or nitrogen or whatever. And they know the colors they need to represent. The human eye does not see as well as the camera can see. Classic example of that is the aurora. If you go to Norway or Alaska and look at the aurora, what you see with your camera and what you see with your naked eye are not necessarily the same. The aurora can be spectacular, but more often than not, the colors will be muted with the naked eye, but much better in the camera. And it's exactly the same thing with the Hubble images. They are real pictures, interpreting the data and interpreting the monochrome light at the various levels, the various densities, to give us the colors we see in those fantastic images. It's a complicated process, but it's the way we've been getting images from other space telescopes or spacecraft going past Jupiter, Mars, New Horizons, around Aricot and things like that. So thanks for that. And I think I've answered all the questions we've had asked of us recently. I was just talking about my photographs. I think I've mentioned them. You'll notice the Manx flag behind me. I had to have a Manx flag behind me. That's the calendar. Manx flag's the other side. That side. No, I can't do it. Never mind. The beauty of using videos, you can't point at things, but it's just behind my left ear. Or is it my right ear? It's that ear. Just scrolling through, see if there's any more coming through. Education for children we've mentioned. Surprising. One of the other great surprises, the Hubble Space Telescope, incidentally, was that deep space image, that idea of taking the telescope and putting it on a tiny, tiny part of the sky, which we thought was empty, and discovering all those galaxies. It wasn't so much a discovery as a realization that space is not empty in that particular fragment of the sky. And as you saw from our little exercise, we did 165 billion other galaxies. And Hubble, of course, saw that there wasn't one, there was two. And now, of course, we've got 165 billion and counting, to be fair. So unless there's any more questions, we've had 13 questions. I think we've covered them all. If I haven't, please feel free to text me with another question. They're coming out as I speak here in front of me. But it's been a great pleasure to do this. I do hope you enjoy Space Week on Viking.TV. You've got some fantastic guests coming up during the course of the week. Charlie Armstrong, I know, an ex-shuttle astronaut. He was on board the Orion with us when we did the shakedown cruise. One of the few astronauts to go into space 3 times in quick succession. And he's been spoken to on with Anne Diamond. I think he's on Thursday. You have to check the details of that one. And there's another couple of astronauts we'll be talking to. And one of the other Viking resident astronomers, Ray Arvidsson, amazing. What does he do for a living? He drives rovers around Mars. I mean, come on. I mean, what sort of job's that? You know. And amongst other things, Ray is heavily involved in the Mars program, Mars exploration program. And of course, a very exciting time for us because Mars is going up into it's got 3 spacecraft on the way to Mars at the moment, and they're all going to get there next February. So we're anticipating all sorts of excitement. I've got a special Mars lecture, which I'm hoping to deliver on board a ship sometime next year. But by the time they get to Mars, I'm sure the lecture will be changed as well. So unless we have any other further questions, as I say, it's been a great pleasure to talk to you tonight, and or daytime, wherever you are living. Another question has just come in. Does this reinforce the notion that we're not alone? 100% certainly. There must be life elsewhere in our universe. You'll have to come on board Viking again soon and let me do my SETI lecture for you, the search for extraterrestrial intelligence. I won't go into the details now, but there's a famous equation. It's been not used much now, but the Drake equation is a great vehicle to do a talk on. And on this lecture, we actually weigh the possibility of life existing elsewhere in the universe. And we've already got places like Mars, we've got Enceladus around Saturn, we've got Europa around Jupiter. And only a few weeks ago, they've discovered phosphine in the upper atmosphere of Venus. And the only reason you get phosphine is by biological processes. So is there life in the upper atmosphere of Venus? Who knows? If you'd asked me that question 6 months ago, I'd have said no, totally inhospitable, and you've got no chance. But now we've discovered this phosphine, and just Coincidentally, on the 15th of this month, the Bepi Colombo, a European spacecraft, is flying past Venus on its way to Mercury. They're doing a gravitational swing by Venus twice to get to Mercury, and they're going to turn the instrumentation on to test it, obviously, but at the same time, they're going to see if they can detect any more elements or any more indications of life existing in the upper atmosphere of Venus. What is incredible is life is a very hardy thing. We know about life existing in the deep the oceans of the Earth and the black smokers down at the thermal ridges of the Earth. And life is very hardy. And if it can evolve and it can start to exist, I'm not saying you're going to get sentient beings and things like ourselves talking about it. Who knows what that will be? But I'm sure that there's other life elsewhere, not just in the greater universe or our galaxy, but I will not be at all surprised if we find evidence of primitive life having existed previously on the planet Mars. Another question from Odell here. Was there ever a wish you had to go into space as an astronaut as yourself? Most certainly, I'd love to have done it. And one of my greatest pleasures is when I'm on board a ship and someone comes up to me and says, "And which shuttle mission were you on, Mr. Parkin?" I wish. No, I did have ambitions to do it, but the British Isles, yes, we've had I've forgotten his name for a minute. Tim Peake, of course, went into space to the shuttle, the ISS, a few years ago now. It's a very difficult business to get into, but for any youngsters watching, you can do anything you want. And if you've got the ability to persevere and to really push for what you want, you can dream and do anything. I don't think I will ever go into space. I'm approaching the age when, well, not quite, but the age when John Glenn was when he went into space the second time. I don't think I will. Maybe as a space tourist, maybe, I wonder if Viking had a trip up into space. I could go and lecture on board the space station. There's an idea, but we'll see. Someone else has just said, Sherwood from San Diego. Oh, thank you. Thank you me for the talk. Hopes to meet on board a Viking ship sometime soon and looking at the skies without light pollution. We haven't spoken about that, but that's one thing I love doing on Viking is we go on deck 9, the top deck near the sports centre, where we've got the dome actually sticks out over the top of that part. But we get them to turn the lights off. If you're on board the Viking Jupiter or indeed the Viking Orion, you'll notice they've got red lights on the golf course. We put them on board. We decided to do that to allow astronomers like myself to do stargazing. And we do get some fantastic clear skies when you're cruising especially the waters of the Caribbean or the equatorial regions around Southeast Asia, this sort of place. And you really can just sit there on a warm, balmy evening and see the wonders of the Milky Way for yourself. And one of the greatest kicks I ever get is showing people the International Space Station going over. And I've done that on more than one occasion. And, you know, people clap and they cheer and they just love it. And I love doing it. And stargazing, giving the lectures is great. Doing presentations in the dome is great, but stargazing on deck really is something special. And we can talk about it in the theatre, we can talk about it in the dome, and then go outside and see it for ourselves. It's always great fun, and long may it continue. And as I say, I'm as frustrated as everybody else is about the fact that we can't cruise at the moment, but hopefully, as I said earlier, we'll be doing that quite soon. Okay, any more else? Anyone else got anything for us? I think we've covered everything. If so, it reminds me to thank very much indeed James and the team for putting this together and for inviting me to come along and do this as a first talk in Space Week. And I hope to see you on board a Viking ship in the not too distant future. And in the meantime, if anyone's got any questions, please feel free to get in touch with Viking and they can forward them on to me. And I'd be happy to answer any questions or indeed have a chat with you as appropriate on board a ship, as I say, in the not too distant future.